Okay, guys, this is the second workshop we are starting today, and we are on the training session. And today, John Saya, Alexi, and Daniel are going to train us. And please feel free to start anytime. Stage is yours, guys, and introduce us to topic and deliver it as you like it.
Okay, we can start, right?
Yes, please.
Okay, hello everybody. Nice to see you all. And today is our turn to teach you. And our group is me with Jean Saya and Daniar. So at that point. And our topic for today is energy and carbon footprint reduction in terms of the modern assessment system of green buildings. So I will briefly tell you what we are going to talk about, what we are going to do. So first I will make some introduction part. I will tell you about the energy in the world and in Kazakhstan, about the energy consumption. Then we will talk about the building energy, building carbon emissions. We will take a look at the short video about the low carbon buildings. And then we will go through the certification systems, LEED, WELL, BREEAM, Green Globes. And pay attention, please, because at the end we will have a short quiz with 12 questions. So next slide, please, Jamsaya. Well, let's first talk about the energy itself and the energy consumption in the world. In that graph, you see that the total energy consumption by sources, and here we can see that oil products are still the main in the world for energy, for making energy, and we can see that the energy consumption is growing. So for the past 25 years, 35 years, regardless that we are talking about green economy, green technologies, the consumption of energy in terms of oil product sources are growing up. Okay, next slide, please. So in Kazakhstan, the situation is a bit different. So we have the main source as a coal, and oil products are at the second place. But the picture is a bit different. We have kind of a gap in the late 90s, early 2000s, but now it's already growing, and now we can see that the coal is kind of dropping a bit in the past years. Okay, next. And here is the chart about the Kazakhstan energy consumption by the sectors. So we can see, and basically the picture is the same for around the globe, because the industry is in the first place and the buildings, they are on the second place. So the transportation and the farming and other, they are a little bit lower than industry and buildings here. Okay, next. So what about the energy used in buildings? Why do we need energy in buildings, and what we are doing with the energy? So we basically use it as for maintaining a comfortable indoor environment first. In terms of thermal comfort, we are heating our buildings when it's cold, and we are cooling them when it's hot. So we are trying to maintain the proper air quality using some ventilation systems. Of course, the electric lights are important, and the next slide you will see some interesting fact about the electric lights and cooling. So of course, the domestic hot water and other electrical equipment like refrigerators, computers, TV, all this consumes energy, and all these are energy used in buildings. Okay, next. So with that graph, you can see that the total consumption of energy in buildings, they're growing up for 20 years almost. But the interesting part here that we can see is the space cooling and lighting they are rapidly growing here, and this is what kind of this is kind of a new for the past 20 years, because we didn't cooling our buildings in the past, and now it's a kind of a trend. And of course the number of lightning, the number of equipment, electrical equipment in our buildings, they're rising, so the lightning is rising as well. Okay, next. So what about the building's carbon footprint? This is a chart, and you can see that building generally it's about 40% of annual global greenhouse gases emissions, and it's almost a half. So that is a huge number. So it's more than in that than industry and transportation. Okay, next. So the kind of a hyped topic now is embodied carbon, and everybody in the green building industry, they are talking about the embodied carbon. And what is the embodied carbon? So basically, when we are talking about the energy consumption in buildings, we only kind of consider an operational type of energy consumption. But now we are trying to see it at another point. So embodied carbon is all the carbon emissions that associated with building construction, with extract the raw materials, transport to the factory, then manufacture the products, transport to the site. So all this sequence of operations, they are kind of associated with emissions of greenhouse gases. And past few years, people try to decrease the amount of carbon at each stage of the production of the building, I don't know, materials, construction, in the construction site itself. And that is a big part now. So we have to consider it regarding the carbon footprint reduction. Okay, next. And here you can see that it's almost 30% of embodied carbon in the total structure of annual global building sector emissions of CO2. Next. And now I would like Zhansaya to help me with the YouTube video. And this is the video about the low carbon buildings and how we can achieve the low carbon goals in terms of buildings and different type of buildings. What should we do? What steps should we take? Please. It's 2.5 minutes, I think. It won't be long. Zhansaya, there is no sound. No sound, Zhansaya.
Carbon building standards will be a key component in addressing the impacts of climate change. For decades now, there's been an environmental movement raising important questions and inspiring more sustainable solutions. Just compare yesterday's gas guzzlers to today's electric vehicles, or how recycling has almost become second nature. Over the next 10, 20, 30 years, zero net carbon will be a key component in addressing the impacts of climate change we are now facing. You might be wondering, what exactly is a zero net carbon or ZNC building? In a nutshell, ZNC buildings have three characteristics. They are energy efficient, they are fully electric, and they use carbon-free energy sources, such as solar or wind, to meet operational energy needs. This concept applies to all building types: homes, businesses, schools, fire stations, you name it. A ZNC building starts with energy efficiency. One of the simplest ways to improve efficiency in an existing building would be to install LEDs or use natural light and buy Energy Star labeled equipment and appliances. Did you know natural lighting has been proven to improve learning in classrooms and employee productivity? ZNC buildings feature ideal interior climates and less noise pollution due to energy efficient insulation. New technologies like smart thermostats work with these improvements to only use energy when and where it's needed. ZNC buildings must also be fully electric because natural gas, which is mostly methane, produces greenhouse gases and decreases indoor air quality. Efficient electric options such as induction cooktops and heat pumps for heating spaces, cooling spaces, and heating water are already widely available. The third key part of a ZNC building is ensuring the energy used is carbon-free. Harnessing the power of the sun will go a long way to make that happen. The costs to install solar have declined dramatically, simplifying the decision to choose solar energy production. Even better is when on-site solar generation is paired with battery storage and electric vehicle charging stations to add both convenience and reliability. For buildings that are not well suited for solar or can't generate enough energy to meet their needs, ZNC is still achievable by purchasing 100% carbon-free or renewable electricity from your power provider. The strongest ZNC benefit is the improvement in quality of life for you, your family, and the community, with utility cost savings, cleaner air, and more comfortable living spaces. Moving toward a fossil fuel-free future is a bold but necessary goal, and the implementation of ZNC building components is a huge step in the right direction. To learn more about ZNC and steps you can take now toward this future, check out these resources.
Okay, thank you very much, Zhansaya. So the first thing, what zero carbon emission building should be is it should be energy efficient, right? The second thing, it should use electricity instead of other sources of energy. And the third part, it should be kind of trying to use some alternative energy sources like solar radiation or wind or something. This is the main three components of the low carbon buildings. And I didn't tell you the main part. Why do we need? Why do we want our buildings to be low carbon and low energy, more energy efficient? Because the main thing that is, you see that the energy consumption and energy production in the world is growing up, and the buildings itself, the areas of buildings, they're growing up. The population of the Earth is growing up. So we need to find a solution how to reduce the energy consumption. And the second thing is that the saving, your savings in terms of money, because, and this is maybe the most important part, because we don't want to spend a lot of money for heating and cooling our buildings, for electricity or something. And this is, I think, the main point in that case, which forced us to find a solution in low carbon technologies, in low carbon buildings. Okay, next slide, Zhansaya. So these are 4 different assessment systems that we went through, and the LEED is mine, and the WELL well is mine also. So the BREEAM and Green Globes, the guys will follow up and talk about them later. So in terms of energy, we should know that, we should remember that LEED and the other Green Star assessment system, they kind of consider energy as the key category in their systems. So for them, the energy consumption and the energy efficiency is very important, because there are some different type of assessment systems that that don't clearly consider the energy as the main kind of as the main part, and I will talk about them later. Okay, next, Zhansaya. So as we know, LEED is well famous around the world energy assessment, well-known assessment system in the world. So but it's kind of a close, so you are not allowed to get a free access to all the information about the system. So, but you can use this link that you can see on the slide to go to the kind of overview site with all the descriptions about the system. But now at this table, I have compound the energy and atmosphere areas in LEED. So you can see that it's totally 33 points, and some of these subcategories are required, and some of them are just assessed by points. So, and for example, I just give you here brief information about for example, fundamental commission and verification, the first kind of required procedure here in the LEED. And it's all about that the commission should be involved in testing the equipment, the HVAC equipment, electrical, plumbing, renewable energy. So, and for example, the second one, minimum energy performance, it's about the procedure when you should go with the simulation of your building, and then you can compare it with the codes with the code of your country, I don't know, and then you can see if your building is more energy efficient or not. If it's more energy efficient, you should achieve your goal should be that your building should be more energy efficient that the codes kind of ask you to this building to be. Okay, so but you can use the link, and I mean during the discussion on Thursday, right? You can use the link to kind of get all the information that you need. Okay, next. And for example, this well, I've made a mistake. This is a WELL should be so, but it's okay, I think. Well, this wheel system is different because they more focus on the kind of interior parts of the building, how to make it comfortable for living, how to increase the comfort, how to increase the air quality, how to make the comfortable environment inside your building, how to provide all you need for making it for kind of a work and live. And they are not consider the energy like the most important part. But in that table, I kind of gather some information that can be more or less connected with the energy consumption and the food carbon print reduction. So you can see there is a ventilation effectiveness, the in-chains ventilation, operable windows, the thermal performance of the buildings. And you can see that in that system, it's very, very similar to LEED in terms of points, in terms of preconditions, and it's basically like the same. You get the point if you met some system expectations. So at that point, I told you everything that I want to. So I want the guys to follow up. I think the next will be Jansaya. Thank you very much, guys, for listening. And Jansaya, go ahead, please.
Thank you, Alexey. Now I'm going to talk about BREEAM certification. And you can hear me?
Yes.
Okay. And now I'm going to talk about BREEAM certification. BREEAM certification is an environmental assessment method for existing non-domestic buildings. It's a standard, easy-to-use assessment methodology and the independent certification process. And it improves environmental performance and the building management. And it identifies parts of property portfolio that area underperforming and may require refurbishment. And it's ongoing assessment method to encourage continual improvements. And you can check this site and give more information about BREEAM certification. Now I'm going to talk about issues that are covered within BREEAM. It's energy, water, material, transport, waste, pollution, health and well-being, management, and the land use. And today we can talk more about the energy and the pollution. And here's what are the benefits of BREEAM certification? It's a reduction of running cost, best practice, company green image. It's international, cooperative social responsibility, higher rent or property marketability, benchmarkers for improvements, and reduce environmental impact. Now I'm going to talk about the aim of this certification. The aim of the certification is to encourage designers to take a holistic view to an efficient energy strategy in a building, rather than solely reducing energy or replacing fossil fuels with renewables. And now here's the BREEAM rating benchmarks. And the BREEAM is used to assess various processes, including procurement, design, construction, and the actual operation of a development. And to do this, they are measured against performance benchmarks and can only be carried out by licensed assessors like BREEAM specialists. And the ones this score is known in the build are normally referred by the classification of paths, unclassified paths, good, very good, excellent, and outstanding. Here's the benefits of BREEAM certification. A higher EPC of energy performance ratio can lead to reduced running cost, energy bills, and a lower carbon footprint over the life of the development. And its facility for brand imaging or marketing of sustainability credentials. Increase building life before becoming obsolete, longer retention of tenants, and the higher yields. Here's the carbon emissions. The whole life figures illustrate have been calculated in line with the modular structure of EN 15978 and account for all components making up carbon emissions calculated over a 6-year life cycle. And the life cycle. And as a decarbonization scenario used slope regression from the national grid future energy scenarios. And the 24% reduction in CO2 BREEAM assessed building achieve an average 22% reduction in CO2 emissions compared to building designed to regulatory minimum performance requirements. And the BREEAM excellent buildings save more than 30%, and outstanding rate buildings in excess of 50%. And this huge reduction in CO2 emissions by BREEAM assessed building will ensure that in 2016 sees a rise in number of companies applying for assessment. And then here's the calculation of an energy performance ratio for new construction using BREEAMs. And here you can see the BREEAM credits and the index of energy performance ratio for new construction. And here's the minimum requirements. And the BREEAM excellent requires a minimum energy performance ratio for new construction of 0.36 and the 25% reduction in CO2 emissions arising from regulated building energy consumption. And the BREEAM outstanding requires a minimum energy performance ratio for new construction of 0.6. It's 10 credits and the 40% reduction in CO2 emissions arising from regulated building energy consumption. The 15 credits require a minimum energy performance ratio for new construction of 0.9 and the 100% reduction in CO2 emissions arising from regulated building energy consumption. Here the minimum BREEAM standards by rating level, and it's you can see the reduction of CO2 emissions, and levels excellent is 6 credits, and outstanding level rating level is 10 credits. And here the standards for low or zero carbon technologies. It's in excellent rating level is 1 credit, and on outstanding the same. And here's the more information in this link. Now I'm going to talk about 1 angle square in United Kingdom. And here it is located in Manchester, and the BREEAM rating of this building is outstanding. And the results of BREEAM certification that energy plus building produce more energy than imports, and 80% fewer carbon emissions, 50% less energy consumption, and it saves 500,000 sterling per annual. And now my colleague Danyar will talk about Green Globe certification. Thank you.
Can you hear me?
Yes, we can.
Yes.
Yes, yes.
Okay. Thank you, Zhansoya. Okay, so the Green Globes is an online green building rating and certification tool that is used primarily in Canada and the USA. In Canada, the following Green Globes modules are available: Green Globes for new construction and the Green Globes for sustainable interiors. Also, there is Green Globes for existing buildings that I didn't mention here. That is used for the USA. These modules can be used for a wide range of commercial, institutional, and multi-residential building types, including offices, schools, hospitals, hotels, academic and industrial facilities, warehouses, laboratories, sports facilities, and multi-residential buildings. Next slide, please. Okay, so the Green Globes rating system is accomplished in 3 main steps, which is first one is account creation, and then there is project registration, and then the third part is third-party verification, which makes Green Globes significantly less time-consuming than, for example, LEED, as you can see on the table. Also on the table, you can see that cost of the Green Globes is significantly less, although those are not specific numbers, but so the way the cost is calculated in Green Globes is just according to the gross floor area of the building. Also, you can see the other differences, like Green Globes doesn't have any prerequisites. There are more like force certifications and so on. On the left, you can see that Green Globes has 4 ratings, 4 main ratings, and those are 4 Green Globes, 3 Green Globes, 2 and 1. The rating you get is based off the score you get out of maximum 1,000 points. Okay, next slide, please. Okay, so the Green Globes consider themselves to be a flexible rating system. They have not applicable option for some criteria that are not relevant to a project. It is used where it is impossible for a project to meet certain criteria, or where regional conditions constrain the project. So many Green Globes criteria use threshold responses, allowing the project to obtain credits depending on the level of achievement. In addition, third-party assessors are able to award partial credit for achievements based on their professional judgment. So on the table, you can see that the project management is 50 points, site is 115, energy is 390, water is 110, and so on. So we can see that the energy takes the huge part in this in the rating system, which is 390 out of 1,000. And in the next slide, you can see how those 390 points are distributed Can you show the next slide, please? Okay, so so this is how the points are distributed among the energy category. So you can see that energy performance takes up to 100 points. I will talk about energy performance a little in the next slide, but for now, energy demand is basically heating, lighting, and the power of the building, of how efficient it is, and then the metering and measurement is basically like, do you have the metering for the heating, lighting, and the power? So there is a building opaque envelope, which assesses the efficient orientation of the building, thermal resistance of the building. Lighting assesses the automatic light of the building, the power density of the light, and then the HVAC, which is heating, ventilation, and air conditioning, assesses like whether these systems are automated, are they controlled, is the cooling base heating how good is the efficiency of the cooling base heating and the ventilation. Other HVAC is basically if your building has non-traditional type of heating, ventilation, and air conditioning. Other energy efficient equipment is basically efficiency of elevators, escalators, efficient light bulbs, and so on. And then renewable energy. So what they assess there is basically, have you taken any kind of measures for renewable energy? Did you test your renewable energy efficiency of the building? And they give you points based on some yes, no questions. Obviously, some questions are not yes, no. For some of them, you have to make calculations. For example, you can get half of the points if you have some part of the requirement only. Okay, so and then there is energy efficient transportation. It's basically is there any parking? Is there electric charging stations? Is there bus station nearby, and so on? Okay, and then you can see the Google Drive link, and I attached a file where you can find all the criteria, sub criteria, more detailed with points. Okay, next slide, please. Okay, so this one is energy performance that I will talk about later, which grants you 100 points. Actually, it can give you more than 100 points. You can see so energy performance can be provided in 4 paths, which is A, B, C, and D. Path A is Energy Star Target Finder. So basically what Green Globes allows you to do is to use other assessment tools in order to calculate the performance, and you will still be granted with points for energy performance in Green Globes. So you can get maximum of 100 points, which is obviously in the Energy Star Target Finder. And then there is for Pass B, ASHRAE 90.1, Appendix G, you can get other 100 points if you use the Pass B. If you use Pass C, is the same story, but it is ANCI and the GBI. GBI is the Green Globes initiative. So the Pass C is the one that Green Globes has contributed the most. And you can see that the naming is Energy Performance Building Carbon Dioxide Equivalent, carbon dioxide emissions. And you can get extra 50 points here for amount of decreased carbon dioxide, reduced. And the Pass D is the ASHRAE Building Energy Quotient, another 100 points. And based on the amount of reduced carbon dioxide, you can get another 25 bonus points. So basically, in this criteria, the green globes consider how much reduction did you make in terms of carbon footprint. So now I'm going to talk about the pass C. Can you put the next slide, please? Okay, so why am I talking about pass C is because it is the one that that is made in collaboration of GBI, which is Green Building Initiative, and the ANSI. So this is the formula that they use for calculating the reduction of carbon emissions. So the PR is proposed equivalent emission rate, and the BR is baseline equivalent emission rate. I'm not going to go in detail with the formula. You can see it yourself. So basically, the more reduction you make, the more points you will be awarded in this system. Okay. Can you? Yeah. Thank you. So in this slide, you can see the comparison of different systems of their maximum points and distribution among the world. Okay, you can take a look yourself, and that's it. Do you have any questions?
Okay, thank you very much. It seems that you finished delivering the content.
Yeah, we have a quiz, by the way.
Yeah.
Yeah, we have some.
plan?
We have a
What you are
quiz, a game.
Okay.
If you have questions, we can.
Okay. It is question and answer session. Then there will be some other activities.
Yes.
Guys, please ask.
May I ask a question?
Yes, of course. Go ahead.
Could you open your slide, the beginning? Yeah, this slide about 22% of saving energy. You said that Prima assessed, like the first sentence, which minimum performance requirements you talking about? UK's or our Kazakhstan, or what kind of standards? Is it what?
UK standard, because
okay.
I think in UK the 80% they use BREEAM certification.
Okay, thanks.
Thank you for your question.
Can I ask a question?
Of course,
Yes.
you can.
Go.
Danyar said that in path D, we get 25 extra points. And could you please tell for what? I just skipped.
So basically what I said is there is some specific threshold. When you pass it, for example, you manage to get 20% carbon dioxide reduction. So you get already 100 points. So after those 20%, you get 30% or maybe more. You will get bonus points for that. So that's how you get the bonus points.
Okay, Daniel, why they are giving bonuses? Because this is my understanding that path A and B are just only for energy, but path C is also focusing on emissions as a plus over energy. That's why maybe they are awarding 50% bonus point extra. And it is the same for path D. They are also awarding 25 bonus extra for emissions. This is my understanding. I don't know. What do you think that why they are giving bonuses for path C and D?
Okay, so I'm not gonna lie, I didn't go super in detail with Energy Star and ASHRAE, which is path A and B, but to my assumption, the maximum you get maximum points in that area after having a specific amount of carbon footprint reduction. And in the other pass C and D, as I mentioned, you get extra points when you get more reduction than minimum requirement. I think it's because of this. That's what it's in pass C for sure. I shared the document. I didn't go in detail with other passes. But that's my assumption. Did I answer your question?
Okay, it is not still clear anyway, because it is interesting that why they are, I mean, there are 3 different of certificate here, 4 different type of certificate. Energy Star certificate, Ashari 90.1 2010, and ANSI 2010, and I see that another Ashari standards. So they are giving different points. I mean, 100 point is reasonable for all, but extra points means that maybe those certificate systems are asking for extra performance. I don't know anyway.
Yeah, I can
I think
show you
they
actually.
force you. Yeah, I think they force you to kind of get an extra performance.
Yeah.
If
most
you
probably.
if you can provide a building with some significant, I don't know, energy savings or CO2 reductions, they will give you a points,
I see.
extra points. I think so.
Yeah, can I share the screen? I can show
Yeah,
the.
Daniel, I do understand. Maybe it requires a little bit detailed analysis on these 4 certification systems. I know that it's out of the topic. So yes, okay. I consider that the answer is given. I mean, it seems that they are different. They are. I agree with Alexei. Maybe the PAT C and PAT D are more difficult to get some points with extra enforcements. That might be the reason. I do understand. Okay. Okay. There is no need to go into details. It is understood here. Thank you. Any questions, guys?
I have a question. It's not like a question. Thank you guys for your good presentation. It was amazing. My question is, for example, I know that we have Talent Towers that is LEED certified, but what about Green Globes or BREEAM? Do we have in Kazakhstan examples which was certified buildings?
Okay, so we actually have multiple BREEAM buildings in Kazakhstan. In Kazakhstan, we mainly have BREEAM and LEED, but the Green Globes we don't have. As I mentioned, it's mainly used in the Canada and the USA. So in Kazakhstan, it's mainly BREEAM and LEED.
Okay, thank you.
I think Botagos wanted us to show you the exact kind of examples of the real buildings in Kazakhstan in terms of different certification system, right?
Yes.
Yeah, I can name you some if you want. I have a list. If you wait a little bit.
By the way, while we are waiting here,
it was my gap in terms of finding the examples in Kazakhstan in terms of certified buildings. That's my bad. Sorry.
Astana International Financial Center is certified with BREEAM.
Yeah, as far as I know, most of the buildings, like 30, maybe 32 or 33, they are LEED certified, but only a few, maybe a couple of, like 2 or 3 of them are BREEAM. This is what I know, but anyway, it requires confirmation. By the way, guys, I heard that I mean, the green building certification, what's the name of the council in Kazakhstan? It seems that they have already developed a certification system for Kazakhstan, but I couldn't reach it. So I am communicating with them. If I get some detailed information, I will share with you. And they told that they did such a certification system developed for the country. It was 3 years ago, and it is released, but I have never heard of it. I don't know. Did you hear that there's something Kazakh, a certification system?
No, I didn't.
They say they did, but anyway, if I can find some information, I will share with you later. Okay.
Also, I shared the link in the chat. So it's basically all the projects, green certified projects in Kazakhstan. And on that website, you can see that we have only BREEAM and LEED. And you can go more in detail and see what kind of buildings we have and what kind of rating they get and so on, if you want.
Interesting link. Thank you.
So, Jansaya, if there are no questions, could you please run the quiz?
Yes, of course.
Oh, it seems that BREEAM is more popular than LEED. I was not right. BREEAM is 66, LEED is 29. And the total is 80.
Also, I checked some of the information they provide on the website. Some of the buildings actually duplicate. So actually there are less buildings than they mention.
I see. Okay, thanks for sharing. I will check this link. Okay, let's go on with the code.
Mega Sequoia is BREEAM certified. I'm surprised.
Astana International Financial Center is BREEAM certified. This is a pin code, game pin.
So guys, please connect to the Kahoot game and let's find out who's the best in the energy and carbon reduction.
Oh, can you go back to?
It seems like people are leaving instead of joining.
I think we can start, Jansaya. Push the start button.
Yes. Okay.
5 people are missing, but it's okay. Go on.
Last question. That's all.
Thank you very much.
Thank you.
Patagos, is
Who is
that you?
Yes, I won, but I couldn't able to answer the last two questions because of delays.
you
That's
for
great.
participation.
Congratulations. You are good. You are good.
That's impressive.
Yes, thank you. It was interesting. Okay, guys, thank you very much. Anybody has any question for the organizers? And it is 1 hour training. I think it is good timing. Thank you very much. And what do you think, guys? Are we going to stop now? Do you think that we are ready for the next stage?
Yeah, basically, this is all that we are prepared for today. And I hope that it was interesting to all of you guys. Thank you very much.
It was good. It was good. I like it. But I have one quick question. I couldn't realize that. What is the overall percentage of energy part in the assessment systems in percent? Do you have any quick idea?
I mean, it depends on the system.
So
It's
range, do you have any range? Because it is going to be a kind of idea for us for the next stage. It is like in the range of 20, 30, whatever it is.
for some of the systems, it's really important part. So maybe it's kind of a 30%. For example, LEED and BREEAM, they are very, very focused on the energy.
I see.
Yeah, it's 390 out of 1000 for green globes.
It's even around 40%.
Around, yeah. Okay, that's good. We need such numbers. Okay. So is
But
it
for example, in well,
can give like up to 40% importance or like 20% minimum? I got it. Okay.
yeah, but for example, in well, there is actually I didn't find any kind of strict, direct considering of energy as a key factor.
I see. Because well is more interested in well-being of the residents rather than building itself. I don't understand the logic. Well is in different category, but I am giving a special care on well because I am already working on a project idea like Pansust, how to adopt buildings into pandemic. So I like it because you present it is important for me.
This well system is kind of what you can go with because they have I actually put a link on the slide so you can look at their website, and it's pretty good. It's easy accessible and everything is clear, so you can easily go there and find some interesting stuff because the well system is very, very interested in terms of making a comfortable and comfortable environment inside the building for the living.
That's why I like well. It is a little bit different than the others. The others are focusing on building, but well is focusing on the users. So that's the main difference. I like it. Anyway, guys, thank you very much. It was a smooth delivery, and I like your way of training. Thank you very much, and all your efforts are appreciated. And we will continue on Thursday, and there will be roundtable discussions, and you will switching around the tables, helping people. Okay, guys.
Okay, thank you.
Okay. See you next time. I'm going to upload the file. I'm in the recordings on the drive as soon as possible. Okay, see you next time. Bye, guys.
Thank you. Goodbye.
Thank you for presentation.
See you.
Goodbye.
Thank you.